Hey guys, Mr. Gardner here, and we're on day 4 of our inequalities unit, and today's objective that we're working on is that we want to be able to solve word problems using an inequality with 80% accuracy. So we need to just think back to everything we've done so far this week. We have solved inequality problems by using inverse operations. We have tested solution sets to inequalities to see if they work, if they're true. We have looked at graphing inequalities, which symbols to use, and matching those to their equations. And now we're just going to look at some keywords in word problems, relate some quantities, and solve these word problems using inequalities. So with every type of word problem we're going to work on this year, we're going to do cubes method. That's just a really good strategy for keeping things in order. And so we want to just read through the problem first, and then we're going to make sure we circle, underline, box, and evaluate. So this problem says Jason wants to order some movies from eBay, but can't spend any more than $75. Each movie costs $9, and shipping for the entire order is $3. How many movies could Jason order? So again, with C, we want to circle our numbers. All right. Then we want to underline the question, which is how many movies could Jason order? Okay, and the next thing we want to look at is we want to box key terms here. So can't spend any more than. So that's going to be key to letting us know what's happening in our inequality. We have each. That's going to let us know an operation. So each movie. So this little phrase is going to tell us about the movies and this cost. So that's going to kind of connect to that. And shipping for the entire order is $3. So maybe this phrase here is going to help us too, because that's going to tell us how much the order is to ship, the $3. So now after we box all these terms, we want to just evaluate them. So can't spend any more than. So we want to think about what that means. If I can't spend any more than $75, then let's just think about two quantities. If I can't spend any more than $75, can I spend $76? No, I can't, because I can't spend more than 75. So 76 is more than that, so I can't do that. But I could do $74. So that tells me my relationship with that $75. So I know for the 75 that has to be the biggest part of this inequality, because I can't go above it, so it has to be the biggest. But if I can't spend any more than 75, that doesn't mean I can't spend all 75. So that tells us we have that equality piece. Now we want to think about these other quantities. So we've got $9 each movie. So we have a movie, and each one of them is $9. So let's just kind of think about this. If I added another movie, then that would also be $9. If I added another movie, that would be $9. Now we can think about this. I don't know how many movies we're going to order, but I know how much they cost. And I also know I'm doing the same thing over and over again. I'm adding the same quantity over and over again. And that tells me that these quantities can be multiplication. So it's $9 times the amount of movies I buy is going to tell me how many movies I can buy total from eBay. So I know that $9 times the number of movies is going to be my operation here. So this each is telling me to multiply. And then this says shipping for the entire order is $3. And it doesn't say you're making multiple orders. It says you're making one order. All right, so we know that that's just one $3 charge, so we're adding 3 to our total. Okay, and now if we have an equation here, then we just solve it like we would any of the other inequalities. We're going to get rid of this number here so that we have the variable by itself, because this is going to make 0. So we can cancel that out. And we look over here and we get 0, 0, dot. 75 minus 3 is 72. This inequality symbol stays the same, and we get 9m equals 72, or is less than or equal to 72. Then we're going to divide both sides by 9, because we want to get this m by itself. So then that means m is less than or equal to 72 divided by 9. That is 9 times 8. So that's going to be 8. So that means m is less than or equal to 8. So movies, so we can order 8 or less movies. Right? And that should make sense. We could test it. What's 8 times 9? 8 times 9 equals 72. We add 3, and that's 75. And that fits. Our inequality said that we could spend less than or equal to 75, so that works. Let's just try 10 movies, or 9 movies. So 9 times 9 plus 3. This is going to be 81 plus 3, which is 84. So we wouldn't be able to order 9 movies, so it makes sense that 8 is the maximum amount of movies we could order, because it's on this side of the inequality symbol. Now, if we were going to show that on a graph, then because we have equality, we are going to do a closed circle on 8. And this arrow is going to give us a direction. We're going that way because we're going less than 8. And in a situation like this, you could probably put that it would be to 0 because you really can't order negative movies. And that would be like selling the movie, and that doesn't make a ton of sense. So let's look at one more. So this one's talking about going to a carnival. So let's read about what the question's saying. So to get into a carnival costs $3. Each game is 50 cents. Your mother gives you $10 to spend. What is the maximum number of games you can play? So again, we just want to circle our quantities so we know what quantities we're working with. We want to underline our question. Usually the sentence that has a question mark is going to give away that that's what they're asking. So we want to know what the maximum number of games you can play. So we know our unknown is games. All right, and we can use whatever we want to signify games here. I'm just going to make a box with a G in it for games. Okay, and then I know the carnival, so a ticket. Let's say we're just going to draw a ticket here. One ticket. And that's going to be $3. All right, and then I know that the games, when I'm evaluating this, the games are going to be 50 cents each game, so each. All right. So we know that that 50 cents is going to go with games. We know that that means multiply. So, and then we know that we're adding to our cost, right? If we're buying something and then buying something, then we're adding together those things we're buying. Now, next thing I want to think about is your mother gives you $10 to spend. So if you're given $10 to spend, can you spend $11? No, you don't have it. You only have 10. So that tells us for our $10 quantity that that has to be the biggest. But if your mom gives you $10, can you spend all 10? Of course you can. Unless you got a mom like mine who's like, bring the change back. Then you feel obligated to. But generally speaking, you can spend all of it. All right, so that's going to tell us that we can spend up to that $10. So now if we want to make an equation, we have $3 plus $0.50, so 50 cents, times games, we'll just call that G, has to be less than or equal to 10. Right, and again, it's the same process. This is positive, so we're going to subtract. And that becomes 0, and we get 50 cents per game is less than or equal to $7. So now we can divide by our 50 cents, divide by 0.50, and we get G equals, well, it's not equal, sorry, it's less than or equal to. Let's do our math over here. We have 0.5, we're dividing into 7. Move the decimal once. This decimal will be here, so move it once, bring it to the top, put in our 0. Now we're really looking at how many times does 5 go into 70. So 5 goes into 7 once, subtract 2, bring it down to 0. 5 goes into 24 times. We get 0, so 14. So that tells us that games have to be less than or equal to 14. So we can play up to 14 games before we ran out of our $10. And again, if we wanted to graph that, we would be using a closed circle on 14, and it's going that way because we can play up to 14 games or less. All right, here's another example. Example number 3. Isabel has her own dog sitting service. She charges a flat rate of $10 plus $8 per day. If she leaves a dog sitting job with more than $58, what was the maximum number of days she worked? Solve the inequality and graph. Okay, so again, we want to circle our numbers. $10, $8, $58. All right. We want to underline the question. So we're looking, what was the minimum number of days worked? So we're looking for days worked. All right, we want a box key math term. So rate of $10 plus, well, that's good. That kind of gives it away for us. And per day. So we want to think about that. We also want to think days. So we know we're working with days here, so that's an important number. Okay, more than. There we go. That's another key term there. What's going to tell us something. So that's going to be that we want this to be smaller. If we want more than 58, then 58 has to be the smallest number. So now we can put our quantities together. So we have 58, and we said from this more than that 58 is going to be the small part because we want more than this. Okay, and then we also know that we're getting $10 every day. Or sorry, we're getting $10 no matter what. Plus, that's what this tells us, we're getting $8 per day. We don't know how many days, so that's where we can put our variable in. We'll put a D in for day. Okay, now we have a nice inequality. We have all of our numbers used up, so we know we've used all the information we needed. So now we can start to solve. Again, we've got a positive. We can take away that 10. That becomes 0, and I get 8D is going to be greater than 58 minus 10, which is 48. Divide by 8, because that's being multiplied, so we want to get rid of that by dividing. D is greater than 6. And again, now that we have that greater than sign, and it's not any equality, we're going to use the open circle here, and we're saying it's going this way. And that makes sense too, right? Because we made more than 58. So we're talking about like right at 6, we probably made the 58 right there, right? 4 times 6 is 48. Or sorry, 8 times 6 is 48. Plus 10 is 58. So yeah, that would have been our $58 threshold there. But we want to see when we made more than that. Okay, so then we would have had to have worked 7 days, right? That's really going to be our first day that we could say we worked. That's full. We really don't work like, it doesn't say anything about working half days. And so it's just going to show you that 6 days does not work as an answer, but any number above 6 days is going to work. So that's how you use cubes and your knowledge of inequalities to solve these word problems. Go ahead and do the practice problems that are attached, and then come to office hours if you have any questions.